All right, I'd like to do a brief overview on Chapter 10, even though you're not going to have any homework over it per se. It is important that you're able to identify the equations of these conic sections. All right, so there are 4 conic sections. Not all of them were covered in Chapter 10, however. The circle was covered very early in the semester in Chapter 1, all right? So we won't really see those. But a conic section, okay, is formed by intersecting a plane with this apparatus here, all right? So this apparatus here has a vertex, if you will, okay, and it has what's called a generator, a pole, right? And this pole is going to be tilted a certain number of degrees from the vertical line, and that's going to create an angle theta, right? And then what's going to happen is this pole is going to get rotated, holding that angle steady. So we're going to hold this angle fixed, and we're going to rotate this generator. And if you can see from the diagram, it creates a circle here, and the circles have smaller and smaller radius the closer you get to this vertex here. Now each one of these shapes, they're called a nap. All right, so that's what this is, a nap. Okay, and so what's going to happen when we get conic sections is we're going to take this shape here and we're going to intersect it with a plane. All right, so a conic section is an intersection of a right circular cone with a plane. And depending on the angle of that plane, it's going to create different shapes. So a circle will be formed when the plane is perpendicular to the axis. So we have this vertical axis here, and if we do a plane perpendicular to that, like so, right, the intersection of the plane with the nap is going to create a circle, right? And so the farther the plane is from the vertex, the larger the radius of the circle. Notice this plane is only going to intersect one nap, right? Because it's perpendicular, so it can intersect the upper nap or the lower nap, but that plane is going to be perfectly perpendicular to this vertical axis, right? Now an ellipse is a circle, but it's elongated, right? So the plane is not perpendicular anymore, it's tilted slightly, right? But this plane is still only going to intersect one nap. So if we take a plane and we kind of tilt it a little bit, and now we're intersecting at an angle, you're going to get something that looks like this, where the plane still only intersects either the upper nap or the lower nap. But what's going to happen is you get this elongated circle, right, or this ellipse when that happens. Now, a parabola is the third kind of conic section. So to form a parabola using this apparatus, we're going to tilt the plane to where it's parallel to the generator, right? So here's our generator. We're going to take a plane parallel to that, and we're going to intersect. Now, since it's parallel to a generator, it's still only going to intersect one nap, right? And when it intersects that one nap, it's going to create, if you can see in this diagram here, it's going to create just a this one's like upside down parabola, okay? It's going to create a parabolic shape, right? Now, hyperbola is the name of the fourth conic section, and the fourth conic section is if you have a plane parallel to the axis, and that plane intersects both of these naps, then the intersection of that plane with both naps is going to create a parabola opening up and a parabola opening down. And those parabolas are going to be equidistant from this vertex here, right? We have a space in between those parabolas. So these are the conic sections covered in Chapter 10. There was a lot of work to be done here, finding the foci and the vertices and the major and the minor axis. But with time constraints, we're not going to dive that deep into these. But I would like you to be aware of the 4 different kinds of conic sections and how they're formed. Now, what you are going to have to do is you're going to have to identify from an equation whether the equation is that of a circle, ellipse, parabola, or hyperbola. Okay, so there's this nice handout, right? And I'll take a picture of this and put it in the notes. But there's this nice handout that goes over what the equations are of a parabola, an ellipse, and a hyperbola. Right? And there's some very distinct differences in these equations. Right? So first off, in a parabola, only one, either the x or the y, will be squared. All right, so we have all these equations here, and these are in standard form, and we're not going to worry about that. But in these parabolas, you're either going to get a y squared equals something in terms of an x, or you're going to get an x squared with something in terms of a y. Right? So only one variable is squared when you have a parabola. That's the major difference between a parabola equation and the other two. Now on the other two, on an ellipse, okay, and a hyperbola, both the x and the y's are going to be squared. But what I want you to notice is that in the ellipse equation, okay, here it is in standard form, okay, don't get too scared about it. But if I were to multiply all this out, I'd have a quadratic with the x's, and I'd have a quadratic with the y's. And what's really important here is there's a plus sign in between these two fractions. And so what's going to happen in the equation if we were to multiply all this out is we're going to have both an x squared and a y squared, by, equals 0. But the x squared and the y squared coefficients are going to be positive, right? Now I probably should put some constants out in front of here, right? Because they can have coefficients. So if it's an ellipse, you're going to have an x squared and a y squared, and the signs of the x squared and the y squared should both be positive. In a hyperbola, we're going to have an x squared and a y squared term. But if you notice in the equation of a hyperbola, it's either x squared fraction minus a y squared fraction, or a y squared fraction minus an x squared fraction. So when we write it, when we were to multiply all this out, one of the squared terms is going to be positive, and one of them is going to be negative. So we're looking at things like so. Okay, this would be a sample of a hyperbola because we have both the x squared term and the y squared term, but one's positive and one's negative. Now we can vice versa this. bx plus c, right? So that's the main difference. The ellipse will have both the x squared and the y squared positive, and the hyperbola have one of the x squared or the y squared's negative. Now what's not on here is a circle, and that's because it wasn't covered in chapter 10, but just so we can cover our bases. A circle is going to have both terms positive, okay, but the difference between a circle and an ellipse, in a circle, the coefficient of the x squared and the y squared is 1. It can't be any other number, right? So in an ellipse, we can have a number in front of x squared or a number in front of the y squared, but in a circle, we cannot. Okay, so the coefficient of x squared and y squared must be 1. Right, so I looked at the final exam, and I noticed on the final exam you're just having to identify conic sections from their equation, and so I just want to practice that on the next page. All right, so remember, if only one of the x or the y's are squared, you have a parabola. If you have both x squared and y squared, they're both positive, and there's numbers in front of the x squared and the y squared. This is an ellipse. If you have both x squared and y squared terms, but one of the x squared or y squared terms is negative, you have a hyperbola. And if you have an x squared and a y squared term, but neither of the x squared and the y squareds have a coefficient, meaning if they're 1, then we have a circle. Right? So I have these equations here that I would like to go over with you, all right, and just identify what type of conic section they are. Right? So first, on the first example, we have an x squared term, we have a y squared term. They're both positive, but the x squared coefficient has a constant, right? Both the coefficients aren't 1. So this cannot be a circle, right? This must be an ellipse. So notice I don't care about all the other terms. I'm just focused on the quadratic terms, all right, the squared terms here. So on the next example, if I were to focus on the squared terms, I have a y squared term and an x squared term. The y squared is positive coefficient. The x squared has a negative coefficient. So that tells me that this must be a hyperbola. Right? That's the only one that has one positive, one negative. Here, on this equation, we have an x squared term, but notice we don't have a y squared term. So anytime we only have one squared term, that is indicative of a parabola. So the third one here would be a parabola. Right? This one, x squared plus y squared minus 2x plus 8y minus 6. Just focusing on the quadratic terms here. We have both x squared and y squared. They're both positive, but notice that the leading coefficients are both 1, right? So that's the difference between a circle and an ellipse, because in a circle, we're not going to have a coefficient like we had up here, right? On the ellipse one, we had an x squared and a y squared, but the x squared coefficient was a 4, so that means it can't be a circle. So this one is a circle, right? And one more. We have 2x squared plus 3y squared minus 8x plus 6y. Okay, so just focusing on the squared terms here. We have both x squared and y squared, so that rules out the parabola. Both the terms are positive, so that rules out the hyperbola. And then we have coefficients out in front, so that rules out the circle. So the only thing left here is that this must be an ellipse. All right, so practice if you will. I'm sure there's lots of examples out there about conic sections. Look at the general form of those conic sections and see if you can identify whether they're hyperbolas, ellipses, parabolas, or circles. And if you can do that, you'll be well prepared for the final exam.